Welcome everybody to the twin stick shooter prototype video. Now this is a project within our Game Studio 1 course at the Red River College Polytechnic in the game development program. And so this is just going to be a little bit of a prototype video going over the gameplay as well as the blueprint code, as this game was mainly and mostly constructed using Blueprint visual scripting. So without further ado, let's go check out the blueprint code. So here within the editor, we have our arena map, and this is where our enemies will spawn and try to destroy our player. So before, you saw a little bit of our heads-up display, and let's just start with that as our blueprint. So within here, our widget blueprint, we have three components, which is just a simple UI here for a heads-up display. We simply just have our health component in the top left. In the top right, we have our score incrementer, and in the bottom left, we have a damage boost indicator whenever we pick up our power-up. Now, the health bar is simply just a progress bar, and we've bound that to become a function, which we can check out here in the graph section. And this simply just takes the health bar, and we go and get our player character. We grab the health value from it and divide that value by 100 so it can fit between the range of 0 and 1, and we just simply display that on the health bar. And as well, we've made our score, which is just a text widget. We've made that and bound it to a function, which we can then simply use to cast to our twin stick game mode, grab the score value, and simply just return that and set the text to this value. Lastly, our damage boost is simply just a border widget, and we've set that to a variable so that we're able to interact with it throughout our other blueprints just by toggling off and on the visibility. So that's the heads-up display. Okay, so next let's go check out our BP hero character. And so this is the main character that our player will control. Now, here's a little bit of code here just from a top level view. But if we zoom in, we can just start from the basics here and begin with begin play. Now, begin play is simply just a sequence that will start off and set up a couple things right at the start. So the first item is to set up the laser rifle to be attached to our hero character. So we're going to grab our mesh value, or mesh component, which is right here, skeletal mesh, and to that we are simply spawning a BP laser rifle, which is the rifle, and grabbing its transform, setting that to be our object instance of that blueprint, and attaching this to the rifle socket in our skeletal mesh itself. So this is just simply attaching our rifle to our character, because right now at a base level our character is not holding anything, as you can see. So this just simply attaches the rifle to the character. After that, we just set up our game mode and ensure that it is set to being twin stick mode. So we grab the game mode and ensure that it's set to the actual game mode we want. I know some students have had some problems when deleting folders and it somehow changes default game mode. This just simply makes sure that that will not happen, so that our twin stick mode is always set as the game mode no matter what. Lastly, we set up our heads-up display, which we just saw, and just add that to the viewport. That way we're able to see what we're looking at. And from there, we're able to grab that damage boost status that I alluded to before and use that in order to toggle its visibility. And that'll be gone into more detail when we look at our project edition. So moving along to the movement of our character, like most twin stick shooters, the left thumbstick is to move. So in terms of our game, the x-axis is the forward direction, whereas the y-axis will determine whether our character is moving left or right. So if you are going to the left or right, we're going to add a y value, and vice versa. When you're moving up, we're adding to the x direction. So these are just some simple events that trigger when an input is found with our left thumbstick. And similarly, moving down, like traditional twin stick fashion, the right stick is both to control the rotation as well as whether or not we shoot. So we look up or look right, and we grab that vector, and we're going to make sure that the player is at least a quarter of the way in terms of pressing down the stick in a certain direction. That way it's not finicky in terms of the rotation. We're going to check to see if our player is not dead, of course. That way they do not continue firing or rotating after they're dead. And we simply just set the rotation, and after a quick little delay, just to make sure that our laser bullets fire as desired, we will either pull the trigger or release the trigger based on whether or not our player's holding down the right thumbstick in a direction. So that is the movement and rotation aspects for our hero character. So with that, let's go and check out the enemy character. We'll come back to the other functions here in 1 second. We have our enemy character. Now, to denote a little bit of difference, as you can see in the viewport, we want our enemies to be distinguishable from our player character, so we made them red. And this is done within the construction script, simply just grabbing our mesh value and setting the color to a new color for the body color parameter. And so we just set that to red. Now within the event graph of our enemy character, this is where things get a little spicy. So before we get into here, I'll just quickly go into our AI controller for our enemy character. And as you saw from the little clip at the intro, at the beginning of play, our enemy characters are simply going to track our player every second. And track player is simply just having our AI move to our target actor's location. And so our target actor being the player character, our enemy character will constantly follow the character forever. So that is the AI controller. Moving back to the enemy character, we can see on the viewport, in order to damage, we have a damage volume here. And that's simply just a box collision that we've put at the base, just so that as soon as our character is overlapping this collision, we begin this event, begin overlap. So as soon as we overlap with our hero character, we set the hero. That way we can interact with the value later. And we simply just damage the hero at a rate of attacks per second. And this will constantly happen until we end our overlap. We check to see if the hero, which has been set up here, if we check if we no longer overlap with a hero. If it's true, we then stop damaging the hero. Makes sense, right? And down here is the actual damage hero event. And now this is going to take our instance of our target. We're going to grab a damage amount, which our enemies, our characters are going to be doing 20 damage every time. And this will affect the health. Now, affect health is part of a blueprint interface. And the blueprint interface simply just has this effect health function. And so this is going to be utilized by both the hero character and the enemy character. And so this is what's going to denote how we change the health values for each character. So knowing that this interface works for both the enemy and hero character, if we take a look at before what happens when we call this damage hero event in the enemy character, we will then see that we are calling effect health, which in the case of our hero character, when the effect health event's triggered, we calculate our health, which is the change in our health, which is the damage value provided in delta. And this is just simply adding the negative health value to our current health. And of course, we will die if our health reaches 0. So this calculate health function was just made in a C++ class, and that is just the base class where both our mannequin characters are derived from. So again, we take damage. If we are dead, we will disable input for our player. We will release the trigger of our laser rifle. We will grab ourselves a short delay just to play some nice animation, and simply from the game mode, which we've set, remember, to twin stick mode. From that game mode, we will respawn our player and destroy both the laser rifle and our current self. And this happens almost simultaneously, so we're never going to be able to really run into our old bodies before they are destroyed. So that is what happens when we take damage. Now, speaking of that, let's go and check out the respawn function that was just mentioned in the game mode. So this is the BP twin stick mode, which is the overarching game mode for our twin stick shooter. Now, you saw mentioned previously to our respawn player event. So this will basically take our existing and remaining enemy characters, and for each of them that exist, we will go and loop through and destroy each one before we spawn a new character. And this is just so that none of the existing enemies will overlap with our spawn and interfere with us trying to get back into the level. And afterwards, we spawn ourselves a new BP hero character and allow our player to possess that character. So player index is 0 since this is a single player game, so it makes sense from there. But as well, there is a couple other facets to the game mode, and first that being right at the beginning of the game, we're going to grab all of our enemy spawners, which we'll see in a second, and from that, set the spawner and spawn an enemy at a rate of enemies per second. Now, this doesn't make too much sense until we actually go and look at what this enemy spawner is, which, you guessed, is another blueprint. So let's go open this up. Now, the enemy spawner is this volume above the arena map, and that's what's actually spawning our enemies as they drop down from the sky. So this volume is the enemy spawner. So within this, there is just one event which we've made custom, just called spawn enemy. And we simply just grab all the actors of a class, that being our enemies, and we make sure that we continually spawn an AI from the class BP enemy character until we reach our max enemies limit. Now, we will check within the spawn volume, which is that, again, that volume that was over top of the arena map. And we're going to grab its location, get a skilled box for extent, and essentially what this is doing is grabbing a random point within the box for our enemy to spawn. That way it's just a nice little random dispersion on where our enemies will spawn. So right now this max enemies value is 1, and you might be saying that's not very fun for gameplay if it's just one enemy. But that's not how it works in this case. If we go back to the final event within our game mode, we see our score incrementer. Now the score incrementer is what will adjust our score on the fly whenever we destroy an enemy. So we will take the change in our score as well as our existing score value, add them together and set that as the new value. And every time there is a score which is divisible by 3, if it's true, we will take our max enemies value and increase it by 1. So every time, so the more and more our player gets points, the increasing amount of enemies there will be. So that is the twin stick game mode. Now let's go back to some of the other blueprints. Now, spoiler alert, if you haven't already guessed, our custom implementation to the twin stick project is a damage boost power-up. And this was a sweet power-up asset which has been provided by Cameron Cotty, a classmate within the game dev program, an artist. And we can see this super sweet asset here, which we are using for our damage boost. So we can go and open this up right now. So here is our damage boost power up. And it's just one event, as we see in the viewport. Again, that lovely model. But we have a sphere collision, which is what we're going to use for our player to overlap with in order to activate this power up. So within the event graph, we see on component begin overlap, the sphere collision. We will check to see if our hero character touches it. If so, we'll activate damage boost. And we'll go into that in 1 second. But the rest of this simply just takes the existing glowing light and potion glass, damage boost potion assets, just everything, just toggles the visibility and sets the collision to no collision. That way it just simply disappears. And then after a delay of 10 seconds, or how long the power-up will respawn again, we then reset all of our collision and visibility back to their default states. So once you activate the power-up, it'll be 10 seconds before it shows back up again. So the power-up has been triggered. Let's see what it does. So this is the damage boost event back within our hero character blueprint. Now, again, this activates on pickup. So as soon as we cross over and activate damage boost power up, this is what occurs. We grab the laser rifle object reference, which is attached to our character, and we set the damage boost value to true. We then go in and reset the timer, and I'll go into this in a little more detail when we check out the laser rifle blueprint. And we then set the visibility of our damage boost status for the heads-up display. And so you can see there is a bunch of wires crossing over here and here. And this simply just toggles on and off the visibility in the bottom left corner when our damage boost is activated. We'll play a sound, and the damage boost will last for 8 seconds. So this is what this delay node is doing here. Afterwards, we reset the damage boost value to false, and as well reset the timer, as well as set the visibility, so we do not have a damage boost indicator anymore. So, what happens when you are damage boosted? Well, that functionality happens inside the laser rifle blueprint. So the laser rifle attached to our hero character is what we are dealing with. So to begin, if we jump back to our hero character, just like in most twin stick shooters, whenever we are rotating our character, we are also shooting, aka firing off our pull trigger or release trigger events, depending on whether we are holding down in a direction with our right thumbstick or not. So here are those events. So the pull trigger will do this once, will fire once, and this will continually loop at a rate of shots fired per second. So default to start is 6 shots per second. And this timer is going to be set here and for our weapon, and it will continue to fire until the release trigger event is called, which will then clear the timer for our fire function. So that's pull trigger and release trigger. The actual fire event is down here. So first we will check to see if our damage is boosted. Again, this will only be set to true if our player activates the power-up. So if it is true, we will set ourselves a sound effect based on whether or not we are damage boosted or not. Either way, we are going to spawn a projectile. And the projectile are the laser blasts. Now, again, we saw previously those reset timer events being called within the damage boost event in our hero character blueprint. Right here, we have reset timer. Now, this is basically just making sure that when it's called, we check to see if our rifle is damage boosted. If we are damage boosted, we will set the shots fired per second to 2.5. Now, I wanted to make the damage boost feel powerful, so I wanted the impact to slow down the fire rate. And this is how this works. We set the value. We either are damage boosted or not. So we either set it to the 2.5 or the default 6. Either way, every time reset timer is called, we will clear and invalidate the timer. This case being our fire timer that we set initially whenever we call pull trigger. So we clear and invalidate the timer and just set ourselves a new timer using this new shots fired per second value as the time for when we loop. And so this just changes the attacks per second or the shots fired per second for whether or not we are damage boosted or not. So that is the blueprints for the laser rifle. Finally, let's go check out the actual projectile itself, which is our BP projectile. So there's two events within BP projectile. Right at the beginning of the life cycle of a projectile, we call begin play, and we check to see if the laser rifle of our player is damage boosted. If this is true, normally our projectile is this green bullet, this green laser blast, as well with having some cool particle sparks which are green being emitted on contact. But if we are damage boosted, we're going to change that color to a blue, overriding the base color parameter. We're going to change the emitted light to a blue as well, and set the damage to be 50 instead of our default 20. That way it takes 2 shots to kill an enemy character instead of 5. We will change our sparks to be the damage boosted sparks, and also wanted to increase the actual bullet size. So we're just going to increase our scale a little bit just to increase the bullet size, just to give it that little more extra punch when we shoot. Lastly, if we go down, we have our event actor begin overlap. So this is what happens when our projectile overlaps with an actor. Now, this actor has to have the damageable interface attached to them. Now, that is that function, if you recall, which was our effect health. So both of our characters and our enemy character use this BPI damageable interface. So it's only going to affect anything that has this interface. As well, we want to check to see if our actor is friendly. We have added the friendly tag to our hero character just to make sure that we do not have the ability to damage ourselves with our own bullets. So if both of these cases are true, aka if we hit an enemy character and not ourselves, this is when we call the effect health function for that target. And since the only target is the enemy character after this point, it's basically saying, if we hit the enemy character, affect its health by damage amount. Now the damage, again, is default set to 20, but if you're damage boosted, that will change to 50. And from here, we just set up some particle effects, just spawning an emitter at the point of collision. And once that happens, we just destroy the projectile. So since this is only really going to affect our enemy character, we can check out how that happens in our enemy character blueprint. We saw how our hero character took damage by running into our enemy's box collision, but our enemy character will take damage when it collides with our projectile. And that is the last event here that happens, which is the enemy character's effect health. So again, you can see that it is utilizing that same interface, the BPI damageable, and it is taking the delta, aka the damage amount, and adding that to the current health. And once we check to see if our enemy character is dead, we go to our twin stick mode and increment our score, which we saw earlier. From there, we just make sure that both the collision response to the world and to other pawns are set to ignore. That way, once the enemy character dies, they simply fade away after a duration of 3 seconds for that juicy death animation. And from here, we just destroy the actor. So that is the enemy character. And I think that's pretty much all of the blueprint code that is used within the twin stick shooter. So let's go look at some of the gameplay. All right, so we start off here with a score of 0. And like we saw, the enemies are only gonna start off with 1. So this seems pretty straightforward, right? Yeah, come here. And now that we've reached 1500, you can see our code implementing and working so that there are now 2 enemies spawning. And boom, that was easy. Man, we are so good at this game. It's like we made it or something. And you know what? I think it's time to maybe check out the damage boost power up. So let's go over here and, oh, what do you know? Damage boost. So now it'll take only 2 hits. And as you see, the reset timer event is being called as soon as the power up ends, and a smooth transition back to the regular bullets as well as the fire rate happens. So once again, I'll be just demonstrate that by holding down fire button, picking up the power up, and immediately you see the fire rate change as well as everything other aspect for damage boosted projectile properties. And finally, our health is coming down. So I'm just gonna maybe fast forward this until it gets a little bit too overwhelming, and then you can see our character respond. I was moving too slow. Okay, so that is the twin stick shooter prototype. So thank you for watching, and I hope that you enjoyed the walkthrough of Blueprint code as well as the gameplay. So thank you very much for watching.